Jason, thank you very much, and it's really great to be back with all of you. I really enjoyed meeting with clubs as wonderful as yours. So Jason took me on a little tour of your observatory yesterday, and I think you have more telescopes mounted on the wall than most clubs have in their observatory. So I can't wait to visit it in person once this ridiculous COVID problem ends. One advantage that we've seen from COVID is, of course, a rapid expansion of astronomy, which is really crazy. Most of you know that astronomy manufacturers, telescope sales, have reached a point where it's nearly 400% of their normal order strength, which is why a lot of deliveries are very slow right now. It's been a source of frustration to these companies that they can't get the telescopes and the eyepieces and the things that people want. But it's benefited the league enormously because all of our clubs have been growing. In 1 year, we've gone from 18,000 members to 22,000 members, which is just extraordinary. It's a record size for us. I'll talk a little bit more. It is, and it's really because of the strength of clubs like yours and your presence with us. It makes a big difference. And I'll talk a little more about the league after the presentation. Let me just go ahead and get to that if I can. And I'm going to, can I share yet? My share button doesn't look activated. There it is. Okay. All right, let's go up here, click on this, and okay, let me stop sharing.
Take your time, no problem.
Yeah, that's all right. Oh, there we go.
Okay.
All right. Let's go back to the beginning here. Okay, can everybody see that slide okay?
Yep, looks good.
All right, great. So what we're going to be talking about today is just fun stuff. This will be a relaxing, kind of interesting review of current record holders, both in terms of astronomy and space travel. Please understand that this program has to be updated like every month. The records keep changing, and I'll mention a few of those as we get to them. And I'm trying to decide in what order to pursue these records, and so I'm going to start with things that are close by and just move out at greater and greater distances as time passes, and I think it'll make sense then. So we're going to start with the coldest place ever known to exist in the universe. Oddly enough, that place was in Massachusetts. MIT 2015, Nobel laureate Wolfgang Ketterle and his team used lasers to drain energy from sodium and potassium atoms to produce something called a Bose-Einstein condensate. They reached a temperature in order to achieve this of 1/500 billionth of a degree Kelvin above absolute zero. That's just an extraordinary temperature, and I'd like to show you a little bit about what they actually did. Okay, in a gas, atoms have their own energy, and they have, of course, something called a probability function as to where they're located. All particles have this. As temperature is lowered, the atoms begin to slow down, and one of the aspects of quantum physics is that when energy is lost, the probability function increases in size. That is the location where the atom or the particle is likely to be found. And as you approach absolute zero, get closer and closer, you can't achieve it, of course, but as you approach absolute zero, eventually the probability functions of all the particles begin to get so large that they merge into a condensate. And that is how the coldest temperature ever achieved in the universe that we know of was accomplished in Massachusetts. Okay. Moving on to the largest refractor in the world. It's still the 40-inch at Yerkes Observatory. The telescope is an F19 telescope with a 60-foot long tube. The doublet lens at the top weighs 485 pounds. The observatory was saved by efforts of people who wanted to prevent this incredible site from being destroyed and replaced with condos. You can believe it. Well, what about the largest telescope in the world other than just a refractor? This becomes more complicated. It depends on how you define the largest telescope. One test might be that the multiple mirror telescopes have to be on the same mounting and can form a single image. If that's the test, then the largest telescope in the world is the Large Binocular Telescope at Mount Graham in Arizona. It has twin 330-inch mirrors. Bear in mind the Mount Palomar 200-inch, considerably smaller than either of these mirrors. And they combine to give an effective aperture of 469 inches, and they are mounted on the same mount. They operate together. The largest single aperture telescope, though, is the Gran Telescopio Canarias, which is 410 inches in diameter. And it has less of an effective aperture than the Large Binocular Telescope. But these records will fall probably around 2025 when the extremely large telescope in Chile goes into operation with a 1,547-inch mirror. That is 129 feet across. What about the hottest place ever to exist in the universe? Amazingly, that too is on Earth, at least as far as we know. It occurred in the Large Hadron Collider, where lead ions were rammed together at 99% the speed of light, creating a quark-gluon plasma that achieved a temperature of 9.9 trillion degrees Fahrenheit. That's about 5,500 times hotter than the core of a supernova at maximum collapse. Amazingly enough, back in 1978, a man by the name of Anatoly Bugorsky accidentally stuck his head into the U-70 collider in Russia and caught a 76 billion electron volt proton beam in the head. You can see the path that the proton beam took through his skull. It rendered him deaf in that ear. On that side, he has seizures, and half of his face, or one side of his face, is paralyzed as a result of it. Although I believe he's still alive. He's in his late 70s, almost 80 years old now. Really quite remarkable. What about the worst space-related disaster? Generally, this is regarded to be something called the Nedelin catastrophe, and it occurred on October 24th, 1960, and it involved a missile called the R-16 ICBM being developed by the Soviet Union. The general there, who was in charge of the military missile operation for Russia, was a man by the name of Mitrofan Nedelin, and some interest. Nikita Khrushchev had great interest in this launch taking place before a big celebration in Moscow. And so Nedelin was really hot to trot to get this missile launched effectively so the Soviets could brag about their ICBM capability militarily. Only the rocket had some problems on the second stage right up here. And so General Nedelin went out to personally supervise the attempt to repair the problem on the second stage. And as often happens when the boss goes somewhere, a lot of the subordinates follow the boss because they have to look interested. And so about 140 people went with him to the rocket. They went up the gantry to start tinkering with the second stage. And lo and behold, they accidentally ignited the second stage engine on top of a fully fueled second stage. The result was a catastrophic explosion which killed Nedelin and 91 other people and injured 49 others. The largest impact crater on Earth appears to be the Vredefort Dome in South Africa. This is a dome with a crater surrounding it that is 190 miles in diameter and is thought to be about 2 billion years old. Here is a map showing the largest impact craters on Earth. Ignore this one, that's just a scale down here. The vertifoot dome here is slightly larger, about 10 miles larger than the Chicxulub crater, which of course killed the dinosaurs off. There has been some thought that a larger impact crater has been discovered in in Antarctica, although this is yet to be confirmed, but it's just thought to exist. And if it does prove to be an impact crater, it would be the record holder at about 300 miles, but so far, again, no confirmation of that. What about the largest radio telescope in the world? For that, we have to go to China. Here you see the Eye of the Heavens radio telescope that opened in Jinke Village in Guizhou, China in 2016. It's half a kilometer in diameter, 500 meters, 1,640 feet wide. The oldest astronomical observatory is a Stonehenge-like affair that was discovered in Australia. It's called Werdy Yuan, and it's in Little River, Victoria. It's an Aboriginal Stonehenge, essentially, used to determine the equinoxes, much as Stonehenge was, and it's believed to be 11,000 years old. The first animal in space, other than perhaps a microbe, was a little dog by the name of Laika. Laika was launched aboard Sputnik 2 on November 3, 1957, and this was the Sputnik that people could see easily in the sky. This is the one that really ignited the public interest in what was going on with the Russians and the space program, and certainly ignited our space program. Unfortunately, little Laika was also the first space flight fatality. 5 hours into the flight, the dog died from overheating. The first man and woman in space were Russians. Yuri Gagarin, of course, with one orbit on April 12, 1961, and Valentina Tereshkova in 1963 with her 48 orbits. The first human spaceflight fatality was Vladimir Komarov, who was killed when Soyuz 1's parachutes failed to deploy on landing on April 24, 1967. There were 203 structural flaws in the Soyuz 1 capsule. It was so bad that Yuri Gagarin, who was a very close friend of Komarov's, actually attempted to replace Komarov on the mission because he didn't want his friend to get killed. And the government wouldn't allow Gagarin to go on the mission because he was, of course, a national hero. And sure enough, the parachutes failed and Komarov was killed. However, this really is a death that occurred at the surface of the Earth. The first human spaceflight fatality above the Kármán line, above 100 kilometers altitude, were 3 Russian astronauts aboard Soyuz 11. This occurred on June 29, 1971. When they detached from the service module from their working compartment, sort of a mini space station, the bolts caused rapid, instant cabin pressure depressurization, and they were killed at an altitude of 104 miles above the surface of the Earth. Amazingly enough, their Soyuz 11 capsule landed safely, parachuted safely to the surface of the Earth, but the astronauts were dead long before it reached the Earth. The most time spent in space belongs to a Russian by the name of Gennady Padalka. He has made 5 flights into space between 2002 and 2015 for a total of 879 days in space. The longest single space flight is also a Russian, Valery Polyakov, who spent 441 days in a single mission, covered 187 million miles and over 7,000 orbits of the Earth. What about the human altitude record? Who holds that? Well, that belongs to the United States, and it belongs to, the most space flights, I got ahead of myself here, the most space flights belong to the United States. Jerry Ross and Frank Chang Diaz have both made 7 missions to space. Previously, the record holders were Story Musgrave and John Young, who had 6 each. So these gentlemen have taken 7 launches and 7 safe returns. The human altitude record also, as I alluded to a moment ago, belongs to the United States, and a failed mission, the Apollo 13 mission, which of course suffered the explosion that resulted in the inability of that mission to land on the moon, nonetheless took them to a distance of 249,205 miles from the surface of the Earth, and that remains the altitude record to this date. The first unmanned landing, or the speed record rather, for human space flight is the Apollo 10 mission. They reached the speed of 24,846 miles per hour just before entering the Earth's atmosphere following their 1969 mission. The first unmanned landing on another world was a Russian feat. It was the Luna 9 mission, which landed on February 3rd, 1966, and took this photograph of the surface. The first photograph of the Earth that was taken from the moon was not taken by Apollo astronauts. It was actually taken by the unmanned Lunar Orbiter 1, and this photograph taken on August 23rd, 1966. The first manned landing on another world, we all know what that is, Apollo 11, of course, landing on July 20th, 1969. The Apollo missions also hold the record for longest stay on another world. The Apollo 17 mission remained on the surface of the moon for 3 days and 3 hours. What about the highest known mountain? Well, everyone thinks it's Olympus Mons, but it's actually Rhea Silvia, a mountain on the asteroid Vesta, which rises to a height of 72,178 feet above the average radius of Vesta. Here is a comparison to give you some idea of exactly how the mountains stack up. Here we have Mount Everest down here in white. Mauna Kea is actually a taller mountain because it rises 33,500 feet from the bottom of the ocean to its 14,000 roughly foot height. The highest mountains on Venus, 59,000 feet, Olympus Mons at 69, Rhea Silvia at 72,000. And over here we have Verona Rupes, which is a cliff on Miranda. We'll talk more about that in a little while. Moving on now to the first unmanned landing on another planet. That would be Venera 7, which landed on Venus on December 15th, 1970. Its parachute actually semi-failed on landing, and it went into a free fall, hitting at 37 miles per hour, but was able to survive, and for 53 minutes was able to broadcast some photographs of the surface before the spacecraft failed because of the enormous temperature at the surface. Of course, the surface of Venus, 887 degrees Fahrenheit, measured by Venera 7, and it was under 90 atmospheres of pressure. That's the equivalent pressure of being under 3,000 feet of water. Largest known crevice, of course, is Mariner Valley, Valles Marineris, 2,700 miles long on Mars. Moving out a little bit further, we come to the fastest spacecraft ever launched. That record now belongs to the Parker Solar Probe, which just this past November 21st reached the speed relative to the sun of 586,000 miles per hour. It came within 5.3 million miles of the sun. That's about 6 diameters. The first asteroid landing, that occurred on Eros. The Near Shoemaker mission was able to land on the surface on February 12th of 2001. At that time, the asteroid was 158 million miles from the Earth and shot this image from the surface. We've also, of course, landed on a comet. The first mission to do that was the Philae lander of the Rosetta mission. It landed on Comet 67P Churyumov-Gerasimenko on November 12th, 2014. at a time when it was about 300 million miles from the Earth. The greatest known comet impact was, of course, the Shoemaker-Levy impact with Jupiter, and specifically the G impact, which occurred on, most of the impacts occurred on July 18th of 1994. The G impact, seen here, produced energy equal to 6 teratons of explosive force, roughly equal to 5 million Hiroshimas. To get an idea of what that would have done had it hit the Earth, this will give you a comparison. The most volcanically active known world is Jupiter's moon Io. And here you see a plume from one of its 150 active volcanoes, Tvashtar, which is spewing material to an altitude of 190 miles in this image. The reason, of course, for Io's activity is its proximity to Jupiter and its rotation, which causes Io to stretch one direction and then stretch another, sort of like bending a piece of metal over and over again, generating heat in its core. The largest known natural satellite in the solar system, well, not known, the largest natural satellite in the solar system is, of course, Jupiter's moon Ganymede, which is one of 2 moons in the solar system that are larger than the planet Mercury. It's 3,267 miles in diameter, approaching the size of Mars. And it also harbors the largest known impact structure. Some Japanese scientists announced in August of 2020 that they had determined that from furrows found around the surface of Ganymede that there is a huge impact structure that is actually larger than the diameter of the moon. The impact structure has a diameter of 4,836 miles and was produced apparently by an impactor estimated to be around 50 kilometers in diameter. The largest known storm ever detected is not the Great Red Spot of Jupiter, but rather a transient storm called the Great Springtime Storm on Saturn. This occurred between December of 2010 and August of 2011. The storm was actually eventually 9,000 miles wide and 186,000 miles long. It reached a total of 1.5 billion square miles and would cover an area roughly equal to 8 times the surface of the Earth. The most distant unmanned landing ever effected by humans was, of course, the Huygens lander on the Cassini mission, which landed on Titan on January 14, 2005. At the time, of course, it was 885 million miles from Earth. I promised that we would revisit Verona Rupes, and we will revisit it here. It's on Uranus's moon Miranda. It's a very small moon, about 240 miles in diameter, and the cliff is estimated to be about 65,000 feet high, a little more than 12 miles. Now, interestingly, if you jumped off the top of it because of the low gravity, it would take you 10 seconds to fall 50 feet, so you might think it'd be a fun ride, except the ride would take you 12 minutes and you'd arrive at the bottom at 124 miles per hour, roughly the equivalent of jumping off a 50-story building on Earth. Not advised. The furthest photograph ever taken of Earth was taken by Voyager 1 in 1990, when Voyager was at a distance of 3.7 billion miles from the Earth. The furthest man-made object is, in fact, Voyager 1 also. It's been, of course, in transit for 44 years. It's traveling today at 38,000 miles per hour and is now at a distance of 14.5 billion miles from the Earth. That's about 1/2000th of a light year away from us. It has passed through the heliopause into deep space outside of the influence of the sun. So it's giving us a lot of new information that's very valuable. If it were headed toward Alpha Centauri, which it is not, it would take 76,000 years to get there. It's expected to lose power in about 3 more years. The nearest star to the sun, of course, is our friend Proxima Centauri. In the upper left here, you see Alpha Centauri A and B, which appear as a single star. They're really two sun-like stars. Can you spot Proxima in this picture? Go ahead, take a try. I didn't think you could either. Here it is, right down here. It's a really tough find in a telescope because of the competition in the sky for it. It lies at 4.22 light years, about 25 trillion miles from the Earth, or roughly 8,330 times further than Pluto. The star is about 124,000 miles in diameter, so two of Proxima Centauris would fit neatly between the Earth and the Moon at the Moon's furthest point from the Earth. The closest planet to the solar system that's not part of the solar system is Proxima Centauri's planet Proxima b. This planet has a diameter just slightly larger than the Earth and lies within the habitable zone of Proxima Centauri. Here you see the orbit. The green area is the habitable zone. Another planet called Proxima d is thought to exist in the habitable zone, but hasn't been really confirmed solidly yet. And there's another planet way out, well outside the habitable zone. So it is entirely possible that Proxima b lies in a region where water could exist as a liquid. Before you get excited, though, remember Proxima Centauri is a red dwarf star and is prone to severe flares, which would make life development on the surface of this planet almost impossible. Interestingly, if you were there, however, looking back at us, you'd be looking at Cassiopeia, which would look much like it does from here, only from there would be this 0.4 magnitude star called the Sun, forming yet another zigzag in the constellation of Cassiopeia. The closest supernova remnant to us is one that we're practically in the middle of. It's called the local bubble. It's about 300 light years in diameter, thought to have been created now by some supernovas in the Pleiades moving group about 10 to 20 million years ago. The most sun-like star is one you can see easily. It's magnitude 5.5 in Scorpius. It's 18 Scorpii. Lies at a distance of 45 light years, and look at its similarities to the Sun. Same mass, same luminosity, same diameter, same temperature, same rotation rate, same age. Unbelievable. What about the largest apparent diameter of a star other than the Sun? We know the Sun subtends an angle in the sky of half a degree. What's next? Well, these are the three largest. The largest is R Doradus, which subtends an angle of 0.57 seconds of arc. Mira, 0.56, just slightly smaller. Betelgeuse, 0.46 seconds of arc. And here you see Pluto, Pluto's apparent diameter in comparison to the size of these stars as seen from Earth. The smallest known planet to exist is Kepler 37b. It's only just a tiny bit larger than Earth's moon. It has a 13-day orbit around the star Kepler 37, which lies at a distance of 215 light years from us. The largest known planet is HD 100546b in Hercules. It is about 6.9 times larger in diameter than Jupiter, or roughly 600,000 miles, and lies at a distance of 320 light years. However, it is possibly a brown dwarf star. As you know, the boundary between large planets and small stars gets very fuzzy. It just depends on how much nuclear fusion can be generated by the size of the planet itself. This star is estimated to have an average density roughly equal to that of balsa wood. The darkest known planet is TRES-2b. It's 750 light years away and orbits the star Kepler-1 and Draco. It has a 2,000-degree surface temperature, which is mostly gaseous sodium, which absorbs virtually all of the light that hits it. This planet reflects less than 1% of the light that strikes its surface. The most symmetrical, non-spherical object known to exist is the red rectangle in Monoceros. It lies at a distance of 2,300 light years and is a planetary nebula. What about the record for most planets around a star? Well, we kind of gave that one away. We were tied with Kepler 90 for that record with 9 planets. And when we demoted Pluto, Kepler took over the record all by itself. So Kepler's 9 now holds the record. The coldest place in the universe now, not generated as a Bose-Einstein condensate, is the Boomerang Nebula in Centaurus. The gaseous outflow from the center of this planetary nebula, which moves out at over 300,000 miles per hour, has created temperatures near its center less than 1 degree Kelvin. This planetary lies at a distance of 5,000 light years. The largest known natural satellite ever detected, Ganymede, of course, the largest in the solar system, but we found one larger that lies about 8,000 light years away, and it was detected around the star Kepler 1625. Kepler 1625 was found to have a planet called Kepler 1625b, and it was detected, of course, with the transit method. As the planet transited in front of the star, the brightness dropped, as you can see here, but there was a second little drop that was caused apparently by a moon orbiting this planet, and that moon is thought to be roughly the size of Neptune, so that would hold the record for largest known natural satellite. The hottest known star, a Wolf-Rayet star called Wolf-Rayet 102 in Sagittarius. It's about 9,400 light years away, about half the size of the sun. Surface temperature, though, of 378,000 degrees. It lies right here in the middle of this cloud. Fastest spinning pulsar is this one, found down here. It's PSR J1748 in Sagittarius. It lies 18,000 light years away toward the center of the galaxy. It is spinning at its equator at about 24% the speed of light, 156 million miles per hour. That's about 716 rotations per second. The largest known star is this one. This is Stephenson 218, 2-18 in Scutum. It lies at a distance of 18,900 light years. It has a diameter of 1.8 billion miles, larger than Saturn's orbit. And here you see Earth's orbit around the sun in comparison with Stephenson 2-18. The fastest moving star is actually a star that is making rapid loops around the center of our own galaxy, around the supermassive black hole at the center. This star is S4714 and is whipping around at 8% the speed of light. The furthest known planet to exist is called Sweeps 04, and it has about 3.8 times the mass of Jupiter, and it was detected around a star that lies at a distance of 27,710 light years from Earth. It was detected again using the transit method that showed a slight dimming of the star as the planet passes in front of it. What is the closest galaxy to the Milky Way? Well, that's actually the Canis Major galaxy. This is a galaxy that's basically being absorbed by the Milky Way through collision. It was detected by the 2-mass survey. The core lies at about 42,000 light years from the core of our galaxy in the direction of Canis Major as seen from Earth. The stars from this galaxy have been torn apart and now form loops around the Milky Way, which is seen basically in blue here. The fastest spinning star is VFTS 102 in the Large Magellanic Cloud at a distance of 164,000 light years. It's spinning at 1 million miles per hour at the equator. That's about 100 times faster than our sun rotates. The largest spiral galaxy, this honor goes to the Condor Galaxy in Pavo, NGC 6872. From tip to tip on its spiral arms, the distance is 522,000 light years. This galaxy lies about 200 million light years away. The loneliest galaxy that we've ever found is MCG 01 in Pisces. It lies in a void, part of the Boötes void, and the nearest other galaxy to it is 100 million light years away from it. And so it holds this dubious distinction. Not a good place to observe if you're a galaxy hunter. The largest known galaxy, IC 1101 in Virgo. 100 trillion stars, over 500 times the number of stars in the Milky Way. You see M81 superimposed here at the bottom, just for comparison purposes, to give you an idea how large this galaxy is. From one side of its halo to the other is a distance of 4 million light years. That is approaching double the distance between the Milky Way and Andromeda. This galaxy lies at a distance of 1 billion light years, and you can access it easily with a 16-inch telescope, maybe 14. The hottest place in the universe now, not in a particle collision in the Large Hadron Collider, is a galaxy cluster called RxJ 1347 in Virgo. The cloud of gas that you see here has been measured at 540 million degrees Fahrenheit, and this galaxy cluster is 5 billion light years away. The most massive galaxy cluster known is called El Gordo, which means the fat one. It has a total mass of about 3 quadrillion stars. It lies in the constellation of Phoenix at a distance of 7 billion light years. The largest known structure in the universe is called the Huge Large Quasar Group, and it is a band of 73 quasars that stretch through Leo and Leo Minor. The band is about 4 billion light years long, and on average, the distance to the structure is about 10 billion light years. The largest known black hole is TON 618 in Canes Venatici. Here you see the quasar, which surrounds or harbors this black hole. The black hole itself is 240 billion miles in diameter, its event horizon, which is about 1/25 of a light year. This black hole has a mass of 66 billion solar masses, and here is Neptune's orbit in comparison with the event horizon of this black hole. The brightest known object in the universe, quasar. The brightest known object is quasar APM 08279 in Lynx. This lies at a distance of 12 billion light years and is easily detected in a 20-inch Dob. It's a remarkable object that shines at magnitude plus 15.2, and you're literally looking across the entire observable universe to see it. It's also the wettest place in the universe. It harbors 4,000 times more water than the Milky Way galaxy is expected to harbor. At Arcturus's distance, if this quasar were located 36 light years away from us, it would shine at magnitude minus 45. That would be 16 million times brighter than the sun appears from Earth. The furthest known galaxy is a little red smudge right here. It's called GNZ11. The light travel time from this galaxy is 13.4 billion light years. This is right at the end of the dark era, when galaxies, little proto-galaxies, were just starting to form. GNZ11 has only about 1 billion stars and is only about 600 light years wide, full of brand new hot blue stars. It appears red, of course, because the light's been stretched by passing for so long through expanding space. Today, GNZ11 lies at a distance of 32 billion light years, and it is these galaxies that the James Webb Telescope will be focusing on. They're heavily red in nature, is why the James Webb Telescope has this golden colored mirror to make it more susceptible to detection of heavily red in light and light in the infrared spectrum. The furthest thing ever imaged, of course, is the cosmic microwave background itself. This is light that was first able to travel through space after the universe became transparent, just 380,000 years after the Big Bang. This light's been traveling to us for 13.8 billion years. And that is the state of current record holders to date. And again, I want to thank you for the opportunity to speak with you today. And I'll stop sharing and just take a couple of moments to highlight a couple of things about the Astronomical League that we wanted to talk about at the beginning. The first thing I would say is, again, that we have grown substantially to 22,000 members. We have been blessed with some major bequests lately, enormous bequests that have really put us in a very solid financial footing that we've never been in before. We have wonderful conventions planned for the next several years, actually. We hope to go to Albuquerque this year if the Omicron virus settles down. Next year, 2023, we'll be in Baton Rouge with a tour to Ligo in Mississippi. 2024, we are planning for a joint convention with the RASC in Toronto. That will occur on June 28th through July 1st of 2024. And in 2025, we will be in Bryce Canyon. Lowell Lyon is already organizing that, and a lot of plans are already in place. So if you like dark sky observing, keep that one on your mind as well. Reflector itself, you may have noticed, has expanded now to 36 pages. Has a much better feel to it. And I really hope that many of your members will realize what goes in here. One thing that goes in here are awards you might give to your own members, or recognitions you might give to your own members. Send us a picture, tell us about the member or what this person did. If you have awards that you give out, let us know about it. If you want to write articles or submit pictures, we post these pictures in here for people to see. And if your astrophotography is submitted, it might appear in here as well, or even on the cover. And of course, all observing awards appear in here. To date, the League's observing programs, we have over 80 of them. Many of them are special programs. We have 69 official programs, which are the regular regimens like open clusters, globular clusters, northern ARPs, and so forth. And to date, we've had some 16,500 certificates issued to more than 5,700 different people in the League. It's the most robust observing program in the world. Other nations have them with maybe 5 or 6 programs maximum. And we're very proud of that program. And it's a very popular aspect of League membership. And I know a lot of your members participate in it as well. And if they don't, encourage them to, because it's a lot of fun and it's very infectious. Once you get started, it's hard to stop. And I know that from personal experience. So we hope you'll take advantage of that. The big news currently is that we got tired of our website. Our website has been ridiculously out of date. The website was not attractive. It was not particularly easy to keep updated because it was on the Drupal 7 platform, and our webmaster just couldn't keep everything up to date all by himself. We have award programs on there. We have the store. We have membership databases. Keeping it up to date was nearly impossible. So we have spent nearly $40,000 to have professional services to completely overhaul the website, give it a new look, much better functionality, and transfer it from, or transition it from Drupal 7 to WordPress, a platform for which we have about 8 people ready to maintain it for us. Much easier to maintain. We have a lot more people trained to do that. We expect to have this website up and running by the end of January, this month. And so problems that have occurred in the past with having current club information listed, on having to access the store through a separate site. All of that will be fixed and combined into one new site. So please keep your eye out for that. And Jason, and to all of you, again, I deeply appreciate the invitation to join you again, and I hope you'll have me back again next year.
Absolutely, Chuck. It's as I said, and I started off. As I start off every conversation, I'm so pleased and proud to know you and be part of the Astronomical League and be a part of everything that you guys are focused on. Our club is active. Um, the downstate region of New York is quite active. Our club is one of the most active and one of three major ones located on Long Island. Currently, I believe we're about at 170 members. Where I showed you yesterday, I'd like to say that that was our clubhouse, but that's not our clubhouse. That's the Custer Institute. That's a third club or a third organization out on the east end of Long Island. They're about 170 members strong as well. So, you know, with the AAA in New York City, I think they're probably 600 or so members. I'm not really sure. I think Bart Fried was saying to us the other day, it's about 600 or 700 members. Um, so it was quite a bit of activity. And as you said, you know, fortunate, one of the byproducts of being involved with COVID is that astronomy is through the roof. So this increase of purchasing telescopes has led to the increase of questions and the need for clubs like ours and the clubs you represent to help the people and the individuals learn how to use their scopes and learn how to uh, use the resources that are available to them. So the Astronomical League is a large resource location of the observing programs. AOS's as well has a large repository of self-observing programs so that the members can learn what's out there for them to see. It is always a pleasure to have you join us. As well, we're going to have Aaron Clevenson join us on the first session of February from the Astronomical League. He's going to join us and show us what Chuck was talking about, these 80 or so observing programs that are available that you can do yourself at home, provide the information in the backup in a certain format. The Astronomical League will then send you a certificate for your acknowledgement of your achievement, and your name will then be listed in the Reflector magazine, as Chuck has so kindly mentioned. We have a question from Linda Prince. Linda, go ahead.
Thank you so much, Chuck, for such a great presentation.
Thank you.
I was wondering about that big giant impact crater. Was it on Europa, I think?
Yes. Estimated, yes. No, excuse me, Ganymede.
I'm
It was on
sorry?
Ganymede. Ganymede,
Oh, it was Ganymede. All right.
yes.
Ganymede have the same. Well, I know Europa has a surface gets renewed a lot because the ocean water comes up and freezes, and that's constantly going on. Does that occur in Ganymede as well?
To some extent, but less so. And the surface on Ganymede has remained pretty static. And what they have found, I should have included pictures of the furrows that they were imaging. There are these long semicircular ridges, and they measured the size, the radius of these ridges, and determined that it was just apparently a huge impact. Now that's their theory. It's hard to actually prove that, but it was a fairly rigorously supported article.
Is there any estimate on the age of the impact from?
No, I don't think so. I didn't run into that. Let me see if I made a note of that. Um, no, I don't think they have an estimate of its age.
Okay. All right, thank you.
You're welcome.
Great. So I'm going to open the floor up to anybody who does have a question, as I've posted in the chat. If anybody's looking, if you want, you can raise your hand or you can jump in when you feel. Hey, Steve Bellavia, hello there.
Hi, I just want to say I think it's not fair. Like you were showing quasars that are 12 billion light years away and galaxies that are 13.4 billion. And if they're looking back at us, we don't even exist yet. That's just not fair.
That's the way it is.
That's really cool. I love when stuff like that just blows my mind. I can't wrap my head around something that's further and older than even probably the second generation of, nebula and stars that formed our solar system. It's weird.
I give a talk on cosmic horizons, which I deal with a lot of the observable universe and how far we can see, basically. And what you learn is that anything that lies more than 16 billion light years away from us right now, more than 16 billion light years away, can no longer communicate with us. We can't get light to it. It can't get light to us. And about 97% of all galaxies that you see, like in the Hubble Deep Field, are already unreachable. They're the last photons that will ever reach us from those galaxies left those galaxies long ago, and they're out of communication with us. It's time really does create difficulty in understanding what you see in space, and so that program deals with that issue.
I also like that you showed what the brightness of that quasar would be if it was as close as Arcturus. That's just incredible. How many times brighter than the sun was it? Like
16 million.
Oh my God, that's just crazy. Craziness. Cool. Thank you very much.
You're welcome.
Steve, I'd like to know out of the objects that he showed, which ones are you going to show up on your target screen next?
That rectangular nebula for sure. Absolutely.
I thought you were going to do that one.
Yeah, that one's got to be. That's on my list. I'll have to look it up. I said it's interesting. You showed that large galaxy. The biggest galaxy I've ever imaged is the Tadpole, which is only 195,000 light years across. Not the one that you showed. But
Chuck, which was the largest one again?
Largest what?
The largest galaxy?
IC 1101 in Virgo.
yeah.
Wow. And you said you could see that in a 14-inch scope.
I think you could. It's about magnitude 15, so you're going to need a 12-inch in super dark skies or 14 or 16, I think, to have a good shot at it.
Just inside our reach, Steve, at Custer, in muddy skies of Long Island. We may be able to see it. I don't know. So that being said, does anybody else have any questions for Chuck or any comments? Questions about the Astronomical League, questions about AOS, questions about astronomy in general, questions about club activities on Long Island, questions about 2022, questions about the Astronomical League convention coming up in Albuquerque, New Mexico.
Yeah, stay tuned on that one. We're in discussions already. We're going to be talking to the hotel again and trying to make sure that we're not, heading down a spider hole here to avoid problems with COVID. We think that the virus that Omicron may burn out, by the time the summer starts, as it did last year. We're hoping, but we'll have to wait and see.
So that's a good question, right? So if I went to the Astronomical League, is their hotel
No, it's not up yet.
not up yet?
We're looking at probably putting something up around the 1st of February this time.
Okay.
Because we're going to have to make a decision, by the end of January,
Right.
what arrangements we can make with the hotel in case we can't get registrations because of COVID or it looks bad for the summer. No, we need to have a safety valve.
Sure.
In case things remain in place. But hopefully the website will be up at the end of January, the 1st of February.
Right. Well, I can't wait to see your new website. You heard when I said earlier, we were woefully in need of updating our website as well. We finally, I'd like to say bit the bullet, but we're fortunate enough to have a club member involved with us that you know, with my prodding and poking his eyeballs out consistently, he was able to make our new webpage happen. And now you sunk my battleship because you said you spent $40,000, so I'm
Well,
by a mistake.
that has to do with, bear in mind that we have enormous databases. We have awards databases, we have observing awards databases, we have member databases for Reflector, we have a
Right.
store. All of that functionality has to be subsumed in one place, and that makes it much more complicated. So
Good. All right. So now instead of a steak, I just have to buy him a Coke and a hot dog.
listen, talk to Don Knabb or talk to the folks at the Kalamazoo Astronomical Society. They have created phenomenal websites just individually, just
Right.
working alone. And the Kalamazoo site's spectacular, one of the finest I've ever seen, and great galleries and very colorful.
Kalamazoo
Informative.
website, huh?
Kalamazoo, yeah, beautiful website.
So for the 27 participants that are with us today, our webmaster is with us, Chris Klein. And Chris, take a word from Chuck and go scout out the Kalamazoo website, you know, and see if you can pick up any pointers. Chris has done a wonderful job of making it happen. I'm very proud of what he's done. And I do encourage everybody to, you know, at least stop by and take a look at it. It's very fresh and clean and modern, and it does function very well. We will be making some obvious changes as it goes along. We'll be cleaning up pages. We hope to add a nice members page, member site page. So for all the astrophotographers that are out there that are doing their thing, you'll be able to provide a link to your location, and you know, hopefully utilize our page together with yours, so this way you can get some exposure. So that's really, really good. Again, I'm seem to be hogging up the airways. If anybody has any questions, feel free to jump in. So anybody, real quick?
Jason, it's Chris. So I'm a vegetarian, so we can't do steak, but we'll do something else.
So I'll get you a plant-based hot dog and a Coke.
Okay.
How about that? And actually, I just learned yesterday, after all these years, Colonel Sanders has decided to make a plant-based product now. So we can take you to Colonel Sanders. How about that? All right.
Great.
We can get you wear the hat. Go ahead. Who's jumping in?
Jason,
Yeah, Andy. Hello,
how
Andy.
are you? By the way, Alan, is it possible we can get a list of what you just gave us as a presentation so that we can act smart with people that we want to get interested in astronomy or just want to, you know, give them some highlights?
Well, you have the recording.
Yeah, so
Okay.
Andy, this has been recorded.
Okay.
And you know, you can do that. Weren't you feverishly writing like I was along the way? I know Steve Bellavia jotted down a couple, because I know he's gonna focus out there, right? You know.
Right now, I'm just relaxing, listening to that wonderful presentation. I was
Yeah.
too lazy to write things.
No, that's great, Andy. It's really good to see the top of your head.
Yeah. All right. Yeah. Bet better.
Yeah, there you go.
But it's better to see the pictures on top of my living room. You see with the aurora borealis.
Yeah, no, but it's good to see your face. I mean, you
All
know,
right.
COVID has caused so many people not to see each other anymore. Actually, Andy and I bumped into each other at what, a deli, or where was it? It's about 6 months ago. I
Yeah.
bumped into you.
Well, the last time we saw the eclipse, the partial eclipse on top of the building by Grand Central Station, which
Yeah,
was a great trip for all of us.
yeah.
I'm just hoping we can all get together again, because I don't like these virtual trips. Believe me, you know, it's not like having somebody and talking to you guys personally.
Yeah, no, but it does say wear and tear on the car, though. So it's good to see a lot of your faces here. Mike Siniscalchi, it's good to see you. And Phil Corpus, always good to see you. Nehru, it's good to see your face as well. You know, again, anybody have a question for Chuck? It's, you know, it's great for us to talk, but Patrick, good to see your face. You have a question?
Yeah. Jason?
Yep.
Phil Corpus here.
Go ahead, Phil.
I just have a question. We showed how far quasars are, but I never really got a good definition of what a quasar is. Is a quasar the accretion disk that heats up
It's
very
an early
brightly? So let's
stage.
see if the distance is it the event horizon at that point that lights up? Is it the jets that are thrown off? What is the definition I see is always that it's something that is powered by a black hole. That's
Yes.
not really a definition.
Well, most
So-
galaxies form in the early stages around black holes, which in the early stages of galaxy formation, these black holes accrete stars in their vicinity. And the material is ripped apart and forms a sheet or a disk around the event horizon of the black hole, which creates enormous friction, creates, of course, jets and perpendicular to the rotation of the disk. And this radiation is intensely bright. After a while, most of the stars that are in the vicinity of the black hole are absorbed. It reaches a certain size and the galaxy becomes more stable, such as our own. Now, we still have stars that are orbiting at very high speed around Sagittarius A star, at the center of our galaxy, but they're not being absorbed rapidly at this point. So quasars are just early stage formation of galaxies, large galaxies, and they shine with enormous brightness.
But is it the accretion disk, which is the
Yeah,
heating
essentially.
jet?
Yeah, that's where the friction is occurring. The
So it's the
acceleration
brightness
of the gas is so great. Yeah.
Oh, okay. Thank you.
I have another question.
Right.
The star that had the greatest motion, moved the fastest, was that star that orbits around the black hole at the center of the Milky Way galaxy, and you called it S something.
Yeah.
Um, is that the same as the star S2 that is supposed to be the one that moves the fastest around the black hole? And Andrea Ghez got the Nobel Prize for her research over around 15 years of tracking those stars that are moving rapidly around the black hole. I'm
Which
just
black
wondering,
hole?
is S2, which is supposed to be the fastest one there, is that sort of a shorthand, name for the star that you called S200 and something?
I don't know what S2 is. In other words, I don't know what you're referring to there, but the current listed fastest known, let's see if I can find it. Fastest moving star is S4714, which was clocked at 8% the speed of light in a tight orbit around the black hole at the center of the galaxy.
Yeah,
There are certainly other rapid moving stars that have been detected around other galaxies, other black holes.
Okay. It might be the same star. They may have just given it a short
It's possible.
name, S2. I don't know. Okay.
And somebody asked in writing, did I understand correctly that there's a planet with a moon as big as Neptune? The answer is yes.
That somebody, Chuck, is Sue Rose. And
Oh, hi, Sue.
I'm
Hey,
trying,
Chuck, how you doing?
I'm trying to get her to poke her head out. Joining us, Sue?
I'm here. Oh, I got to stop my video. Sorry about that.
Yeah.
Yeah, when you said that, it kind of caught me off guard. If the moon is as big as Neptune, how big is that planet?
Larger than Jupiter considerably. Let's see, that would be at a distance of.
Yeah, I kind of
It's a long list here, so give me a second.
You kind of caught me off guard when you said that. It perked up my interest when you said the moon is as big as Neptune, and I said, "How the heck big is that planet?"
The planet has a mass 3.8 Jupiter masses, so it's dragging this.
Isn't that at the point where it should be a star already?
Almost, not quite.
I mean, that sounds like a small solar system. That's incredible.
Well, it's interesting that you had mentioned before that we were in the tie for the most amount of planets, right? And then we lost Pluto. And then last week, I guess I read that what is it, the planetary, Sue, you would get the name right, but the people that decided that Pluto wasn't a planet, what is that group?
International Astronomical Union.
Right. So I read last week it was that they said, well, not only is Pluto coming back, but by definition now we have 150 planets.
Oh, jeez.
So if we can make that happen, then we'll take the lead again.
And Sue has offered to create the acronym so our elementary school kids can remember all the planets.
Hey, I just want to let you know, I've already got my plane tickets and I have a reservation at the hotel in Albuquerque. I
Fantastic.
made it last summer.
Fantastic. That's great.
Well,
Can't wait to see you all.
Sue, you make it sound like it's the one and only hotel in Albuquerque, New Mexico.
Well, it's the one that has the deal with the Astronomical League, because I already called them up and spoke to them.
Did you get the block rate?
Yes.
Oh, so which one is that? That's what we were asking.
The
Embassy Suites.
Yeah.
Embassy Suites.
Okay. All right. Well, I
I've
strongly
had my
suggest
reservation for 6 months already.
that if anybody does want to take a trip, not only is it a really good down to earth convention, it's fast, it's quick. It's not like going to Vegas where you have to, spend a lot of money on drinks and bright, glitzy stuff. They're really nice, down to earth people, and they're just like you and I, and just people that really just care about looking up. And for what it's worth, it's really a great convention to just show up at and just put your hand
And I'm
out.
really looking forward to the sequel to it, since it ends on Saturday, the Sunday trip to the VLA.
Yes.
And also maybe to the Antique Telescope Society of John Briggs Museum. I understand you're trying to work out a deal with him.
Correct. Lots of stuff to see out there. And you head
Yes,
down to Carlsbad
absolutely.
Caverns, White Sands. I mean, it's
Meteor Crater,
Yeah.
is not that far a drive away.
that's right.
I
Well,
love
Well,
that.
everything out there is a long drive. But
it is, Sue, let's call a spade a spade. It's an 8-hour drive to the crater.
yeah,
Come on, it's out there. It's wide open space. It's
It's still an 8-hour drive, and then if you are going to the crater, make sure you stop on the corner of Winslow, Arizona, and so you can be part of the Eagle song and stand next to the statue as well, right? But
been there,
yeah.
done that.
yeah, so it's 7 to 8 hour ride out, 7 to 8 hour ride back. You could do it in a day, yes, but it's
when I first visited there in 1973, they had rattlesnake warning signs everywhere. And when I went back there in 2018, they have none.
Really? I
No
remember
more.
the rattlesnake signs because that's about the time that I was there for the first time also.
I didn't see a single one in 2018.
Wow.
I don't know why, but
wow.
they've built it up there a lot more.
So in
Well, the
comparison,
museum is incredible. I mean, there was basically nothing the first time I went there in 74. And when I went back when the heck was it? Maybe around 2008 or 9. The museum was incredible. It was
Wow.
fabulous.
As a friend of mine once humorously pointed out, it was just highly fortuitous that the meteor landed so close to that visitor center.
yeah, any closer I would have taken it out, I'm sure. Well, yeah. Well, like I said, if I can't make anybody do anything, but from the banter that you do here and the candor of Chuck Allen and what they present, I just hope that everybody takes that opportunity at least once. Take the trip, do the convention, enjoy yourself, and recognize that there's people just like yourself in the rest of the country that take the time and enjoy looking up and discovering what's out there. And
And you can see what the skies are like in other places except for Long Island.
right.
You
So-
will make new friends if you go. I mean, it just happens every time you go.
Oh, without a doubt.
Right. Sue, the picture that your background, is that Long Island?
No.
No, I don't think so.
No.
Oh, wait a
In my
second.
mind,
You know what? This one is actually Bill Bradley's photo.
really? Does he have?
Yes,
Do
he
you have,
took this from Long Island. Yes, he did. Yes, he
do you-
did.
do you have his name on there? So there's a little credit in the bottom.
No. No, I don't. So
That is Long-
it's
It
only
is.
in very small print.
Yeah, that is Long Island. I recognize that tree in the lower left. Has Robert Moses Field too. So,
Yeah, yeah.
but
Anyway, Chuck, I can't thank you enough for coming. It was
you.
absolutely
Thank you.
astounding. Thank you so much, and I look forward to seeing you and everybody else.
Thank you, Sue.
6 months' time. Looking
Yes.
forward to it.
Me too. Thank you.
absolutely, absolutely. All right.
Is
So
it possible? Is it possible to just ask one little question more,
Absolutely.
Sure.
Alan? Yeah, when you looked at that last photograph of the furthest galaxy, which is like a red smudge,
Yes.
okay? Now with the James Webb Telescope, what do you think that they might see when they focus in on that object? Do you have any idea? Do they give you some estimation of what they might be able to see?
Well, that's the whole point of the James Webb, because what you saw in GNZ11 was a highly pixelated little red smudge that was blown up from just a little red dot in that photo. It was a blow up. The James Webb's designed to give you a higher resolution view of that proto galaxy, because you can't look much further back in time than GNZ11. That galaxy is seen as it was 400 million years after the Big Bang. Before that was the dark era, before stars formed, before galaxies formed. So we're not going to see much further back in time, but what you will see is much higher resolution images of these proto galaxies that eventually formed, glommed together to form spirals and so forth later on.
Okay. Thank you.
You're welcome.
Yeah, I can't wait to really, I've got my fingers crossed, and we were saying last night at Custer, so you would think that I would pay more attention, because maybe I give the impression that I really pay a lot of attention to what I do. But so I've been following the James Webb and the unfolding, and I'm like, wow, this is great. And then yesterday was the event that the last piece was going to unfold of the mirror. So I said, all right, I'm going to take a look at this, not recognizing that they didn't have a camera, right? This was all just a visualization, artificial visualization on screen. And I was like, why didn't they put a camera on the James Webb? Because it is a camera. Why didn't they just put like a little GoPro, on a selfie stick, right? So that they could beam back the actual, articulation of the pieces, so that they could actually see it. And it was a little deflating to not be able to see it live, because I really thought it was live.
I was talked about, the camera was talked about that the circuitry would heat up. If you have a camera on the visual side of the increased complex circuitry, which also generates heat. Plus the fact the little mini cameras that we have now weren't invented when that telescope was first planned.
Well, yeah, but that was when it was first planned, but we finished it, whatever, 20 years later.
No, they felt heat from the circuitry would be a big problem.
Yeah, but it would have been nice to actually see that. So, but I can't wait to see what this thing's going to do. I mean, in my mind, I'm sure in many of the people that built its mind, it's a success story right now that they've got the origami mirror thing to do whatever it's done so far to date. So, let's get another, what is it? Another, today is the 9th, another 20 days, right? It's gonna hit its final spot. So
I'm actually surprised they haven't focused the Hubble on it to actually get some semblance of, structure.
well, we'll see what happens. I mean, it's definitely everybody's chomping at the bit. So you know,
Jason, it's very possible that maybe they don't want that, because if something went wrong with it and they did that live, wouldn't be good for publicity.
well, I
That's
mean,
a possibility.
you've got a natural, what is it, 3-second delay, right? So they could take it offline.
Well, that's a possibility. You got a point there.
Okay, so it's 3 o'clock. I want to thank everybody. Last call for any questions for Chuck Allen. If nobody has any questions, I want to thank Chuck on behalf of the club. I'd like everybody, if they could, just turn the camera on so Chuck can visually see everybody
Thank you.
clapping for him, and
Thank you
you know,
very much.
people that support the Astronomical League through their club donations. Chuck, as always, a gentleman, a scholar, plethora of information, and I can't wait to see you again soon. I keep trying to get Maynard to come on, but he's busy. Be nice to get him to show up one time, but anyway, thank you everybody. Stay tuned. We hope to have a second session for 2 weeks from now. Just having a problem with locking in a guest, and if we do get the guest worked out, we'll have a second session on 2 Sundays from now. If not, we'll be with Aaron Clevenson on the first Sunday in February, which would be February 6th, the day before my birthday. Not that you guys have to send me a birthday card, but you know, just throwing it out there. So
He pronounces that Clevenson, by the way.
Clevenson. Ah, well, you know, you lose that translation in email, right? So as long
Oh,
as
yeah, I mean, I always thought it was Clevenson too, but he pronounces it Clevenson. So
yeah,
there we go.
he was a hoot on the bow of a cruise ship that night. So
Oh yeah.
yeah, it was really good to have him there. Sue and I were bouncing around on the front of the bow of the Titanic with the wind in our hair. Where's Vadim? Vadim was with us. Vadim disappeared for a couple of minutes and then comes back out with a knapsack and pulls out a 5-inch collapsible Dob telescope, and him and myself were looking at Saturn off the bow of a cruise ship. And I'm like, where did you get that from? He's like, I brought it with me on the plane. And I'm like, you're a madman. So yeah, it was really, really good. Really, really excellent little adventure. I'm sure you will agree if you go and go to a convention yourself, you really like it. So, with that said, I want to thank everybody. Have a great day. Please be healthy,
Take care.
be safe. Take everything into perspective.
Thanks.
Enjoy life and be well.
Thanks again. Bye bye.
Bye bye.
Bye.